See, we're getting close to spring break. Y'all realize that? Okay, so it's kind of weird because normally spring break would be a little bit later in the semester, but because we started a week later than normal, it's not like the midway point. So we still have more weeks after spring break than we did before. Normally spring break is like, okay, we're halfway there, but not really, all right? So we have this week, we have next week, and then there's the break. So this is what we're going to be doing, right? Today we're going to finish up lines. We're going to start the next section. And then on Wednesday we'll do applications of lines with mixture problems. And then on Monday we'll have a review. We'll spend a day doing a review for the test. And then on Wednesday we will have the exam, all right? So on this date, actually, I won't be here, all right? So I'm going out of town on Wednesday, and I won't be back until the middle of spring break. So I'm going to have a proctor come in here, and she's going to just hand the test out. You take the test, you hand them in. And then I'm not going to have them graded until, like, I'll probably get them like midway through spring break. I'll come up to my office and I'll get them. So sorry about that, but, you know, it's the way it's going to be. So just so you know, that's our plan. Okay, any questions? All right, let's get going then. All right, so at the end of class last time, we were talking about parallel and perpendicular lines. And I made some really, really nice drawings for you. And it was just some random stuff I was saying at the end of class. But let's get back and talk about what parallel and perpendicular lines, first of all, what they look like, but then second of all, what is it about the equations of parallel and perpendicular lines that will indicate to us whether or not two lines are parallel or perpendicular. So let's start off with just a quick picture. We pretty much know that parallel lines like this, two lines that are parallel, these lines will have the same slope. Parallel lines have the same slope. So remember that every line can be written as y equals mx plus b. Right? We talked about that already. That's called the slope-intercept form. So if this line right here has a slope of m, then for this line to be parallel, it must also have the same slope, right? So they must have matching slopes. Now to be perpendicular, let me show you. Let me do another line here. Call this one y. Let's call this one right here, instead of m, call it m sub 1. Is that okay? That means it's like the slope of the first line. Compare that to this one. This is the slope of the second line. So for these two to be parallel, those two slopes have to be the same. Make sense if I write it that way? Sure? Okay, so now perpendicular lines, they intersect one another at a right angle, 90 degrees. So that's like a perfect square there, right? That makes sense? We're all familiar with that, yeah? All right. So perpendicular lines, what about the slopes? To be parallel, they have to be exactly the same, right? They have to be equal. But what about if they're perpendicular? So how do you mean opposite? Like if one of them's positive, the other one's negative? Okay? Almost. That's not quite it though. There's something else. Yeah. So this is kind of weird, but this is the relationship we have to have. The slope of the first line has to be equal to negative 1 over the slope of the other line. And when you write it like this, it's confusing to students. So I'm going to just say this in words instead of that equation. They have to be negative slopes, must be what we call negative reciprocals. So I'll show you some examples of slopes that would be perpendicular. So let's say the slope of one of the lines was 3. What would the slope of the line perpendicular to that have to be? So it would have to be the opposite sign, so negative instead of positive, and then the reciprocal of 3, which is 1/3. Make sense? It's this number, 3 is really 3 over 1. We take it, we flip it over, make it 1/3, and we change the sign. Let's do another one. Let's say the slope of one of the lines was negative 2/3. What would the slope of a line perpendicular to that be? Positive 3 over 2. Okay, so you flip it, you change the sign. If it's negative, this one's going to be positive, right? All right, so that's what we'll be looking for. Because what's going to happen now and what's going to happen on the test is I'm going to give you 2 lines and I'm going to ask you, are they parallel? Are they perpendicular? So what you're going to do is you're going to find their slopes and you're going to compare the 2 slopes. It's either going to be this, or it's going to be this, or it's going to be neither. You don't have to be one of these, right? So what about this? What if I told you one of the slopes was 4 and the other slope was just 1/4? Would those be parallel? Well, obviously no, right? They're not the same number. Would these be negative reciprocals? No, right? They're both positive, right? So these would not be perpendicular either. So they'd be neither parallel nor perpendicular. So you can have 2 lines like that, you can have 2 lines like that, but then you can also have 2 lines that hit maybe like this, right? That's not perpendicular. So that would be this case over here. All right, so we have 3 possibilities of what can happen when we have 2 lines. So let's go ahead and do an example. I need to stop using that marker. It's really hard to erase. All right. All right, that one right there I think we can handle now. Bless you. All right, that's enough, please. All right, so determine if the following lines are parallel, perpendicular, or neither. So what do you think for this one? Do we have to do any real work here? No, because these lines are both in the form y equals mx plus b, aren't they? So what's the slope of, this is line 1, so let's call it m1. What's the slope of the first line? Negative 2 over 5, right? And remember, the slope is always just the number, right? It's not the x, it's just the number in front. What's the slope of the second line? 5 over 2. So these are negative reciprocals, right? You flip one over, change the sign, you get the other one, right? So this means that these 2 lines are perpendicular. Agree? All right, let's move on to the next one. Let's do another example before we do number 2. I'm going to make up my own. I'm going to give you 2 lines. So how about this? Let's say L1 is the line 3x minus 4y equals 8. And let's say that L2 is, let's go with 8x plus 6y equals 12. Are these 2 lines parallel, perpendicular, or neither? So what would you have to do first? You have to find what the slope is, right? You have to determine what is the slope of each line. But see, these are not written y equals mx plus b. Like it's not solved for y, right? So you have to do that first. So I'm going to do that for each line. Y'all understand what I mean? Okay, so let's take this line right here. Let's work with this one first. I'll do it over here. 3x minus 4y equals 8. Okay, so we need to try and solve this for y right now. Try and get y by itself. So what would be my first step? Subtract 3x. 3x here. Subtract 3x here. These would cancel, right? What's still over here? Negative 4y is still here. And then over here, remember, you cannot combine these together, right? So this is going to be, I'm going to write negative 3x plus 8. Now what? Divide everything by negative 4, right? Everything. So negative 4 here, negative 4 here, negative 4 here. And let's see what we get. What's my left side now? Y. Then this. What about this? What's this? Negative 3 over negative 4. A negative over a negative is positive, right? So we're going to say that this is positive 3/4 x. And then this right here is negative 2. 8 divided by negative 4 is negative 2. So doing this, we can see what the slope is now, right? That's M1. That's the slope of our first line. Question? You good? You're good? Okay, now we have to do the same thing with the other line. We have to solve for y. So 8x plus 6y equals 12. First step, subtract 8x on both sides. We'll have 6y equals negative 8x plus 12. And then divide through by 6, right? By positive 6. So if we divide through by 6 here, divide through by 6 here, divide through by 6 here, what do we have? Y is, so 8 over 6 or negative 8 over 6. So the top is negative, the bottom is positive, right? So a negative divided by a positive is still negative. So negative 8 over 6x. And then 12 divided by 6 is 2, so plus 2. So this is our second slope, isn't it? Right there? That's M2. So what can you say? Perpendicular. Wait, are these negative reciprocals? They are. So you have to be careful here because this negative 8 over 6, I haven't reduced that fraction, have I? That fraction can be reduced. 2 goes into both, right? So if I put 2 into the top, I get negative 4. If I put 2 into the bottom, I get 3. And now when you look at this and compare it to that, they are negative reciprocals, aren't they? The other one flipped over, changed the sign. So these two lines are in fact perpendicular. Okay? Make sense? Questions, comments, or concerns, or just complaints at all? No? All right. That's it. So on a test, I would expect something like that, where you have to actually go through the process of finding the m and then doing the comparison, rather than me just giving it to you and all you're doing is comparing two numbers. You're going to have to do the algebra for it, which probably seems more exciting to you, right? That seems more fun? More funner-er? No? Look, I know I'm not funny, all right? I'm trying my best to make your 9:30 class a little bit better. All right, next problem, number 2. Something a little different now. Okay, number 2. Find the slope of the line, or the slope of a line, that is parallel to a line passing through those 2 points. What? Okay. We would like to find the slope of a line, only the slope of a line that is parallel to a line that passes through these 2 points. So visually, this is what we have. You don't need to do this like on the test. You don't need to draw this. I'm just make sure you understand what's going on here. If I plot these 2 points, 1, 2, 3, 4, 5, 6, 6 to the left, up 2, that's the point negative 6, 2. We all agree? Then we have another point, 3, negative 4, which means to the right 3, down 4. We have this point. There is a line going through these. Try to make a decent line here. Okay? And what we're asked for is to find the slope of a line that is parallel to this one. Which means what? So you're going to do the formula to find the slope of this line, right? You have to find the slope of this line. And then we want the slope of a line that's parallel to that, which means that it would be the same answer, right? Whatever the slope of this line is the slope of the line we're looking for. So really this problem just comes down to, can you find the slope of the line between those 2 points? And to do that, we use the formula for slope, which we talked about, I believe, last class or the class before. That's the formula for slope if you're given 2 points. So if someone gives you 2 points on a line, there's the formula for finding the slope. Now it's important that you do y's on top, x's on the bottom. Don't do it the other way around. So here's where you have a little bit of freedom to come over to your points and label them. I'm going to call this one x1, y1, this one x2, y2. And you could have done it the other way around. I think someone asked that last class. Could you have done x1, y1, x2, y2? Yes, you'll get the same answer no matter which way you do it, okay? All right, so let's compute our slope. Our slope here is, what's y2? Negative 4. Then I'm going to subtract from that y1. What's y1? 2. And then all of that over x2, which is 3. And then be careful here. Subtract from that, what am I subtracting? Negative 6. So I'm subtracting a negative. When you subtract a negative, it really becomes addition. So what's the numerator? What's the top here? Negative 6. And the denominator is really 3 plus 6. 9? So the answer here is negative 3, nope. Negative 2/3. If we reduce the fraction, 3 goes into the top and bottom, right? So that is the slope. That is the slope of this line, right? But it's also the answer to our question because we wanted it to be we wanted to find the slope of a line that's parallel to it. So we want the same answer. So if that had said perpendicular up here, instead, if this said find the slope of a line perpendicular to the line passing through those points, this would not be our answer. We would take this answer, we'd flip it over, and we would change it to a positive. Understand? Okay. I'm more likely to ask you this problem and say find perpendicular because, you know, there's that added understanding that you have to flip it and change the sign. Let's see what number 3 looks like. Same thing, right? That's the perpendicular. That's number 3. There you go. So the answer to number 3, perpendicular, right? So take that answer, flip it over, make it positive. 3/2. Is that all right? Okay, let's look at this one. This is a little different. Is this line parallel, perpendicular, or neither to a line whose slope is negative 1/3? So they're telling you, hey, look, we've got some line out there that has a slope of negative 1/3. Does this line have the same slope, negative reciprocal, or neither? Is it parallel, perpendicular, or neither? So what are you going to have to do for this to figure it out? What do you have to do? What's that? Yeah, get y equals. So you have to get y by itself. So we have to put this in the form y equals mx plus b. So why don't we do that? How are we going to do that? How do we get y by itself here? Add 3x to both sides. And then I should probably take the 2 out of here too also, right? here, there. Oh, actually I can put the 2 under here, under the 10. Okay, so I'm going to do that, and then over here, this gone, I just have y, and then over here I have 8 plus 3x. So what is the slope of this line? Yes, it's 3, right? That's the slope of that line. So if I take that slope, which is 3 over 1, and I flip it over, I get 1/3. If I change the sign, I get negative 1/3. So this is negative 1/3, right? So these two slopes are negative reciprocals, and so these lines are perpendicular. Understand? Perpendicular. Yes? Okay. All right, moving right along here. I don't know if I want to do this one. Find the slope for each of the following lines. So give you an equation, you have to find its slope. So that means you have to put that as y equals mx plus b. So solve for y there. Then you do the same thing here. Solve for y here. Then you'll have two slopes, right? Then it asks, are they parallel or perpendicular? Same thing for number 6. So why don't we do this in, just as an in-class problem, you're not going to turn it in, but why don't you right now work this problem right here. These are two different lines. First line is right there, this one, and then the second line. Make both of those look like y equals mx plus b. So solve each of them for y, and then figure out what the slopes are, and then see if you can answer this question. And I'll give you, let's say, realistically on a test, this shouldn't take more than 5 minutes, realistically. So let's see if you can do that in 5 minutes. If you have a question, let me know. So that's been 2 minutes. Who has it? I just want to see how many people are done. Okay. It's all right, keep working. I think the first line is probably the one that's the most trouble. Okay, that's about 4 minutes. So I think that would be the expected amount of time. And that's it. We'll call it a day. Thank you all for coming in. I'm just messing with you. All right, so is this one okay? Did y'all look at this one? Is that all right? So this one I stopped in the middle, and that's because I think this is where most people would have trouble. And that's trying to get this y by itself. So like, what do you do here? And when I say what do you do, I mean like, what do you do? Because you can do different things. So, what's that? You're trying to undo multiplication. This is multiplied, right? So you either divide. So how many of you divided by negative 3/5 on both sides? Okay. Then what did the other people do? Oh, so you did like 2 steps. First multiply by 5, then divide by like 3 or something like that? You went and divided by the fraction. Anyone do anything else different? You multiply by the reciprocal? Okay. So you move the y to the other side? Or yeah? Okay. So there's different ways to do this. If I were doing this, I would at this point multiply both sides of the equation by the reciprocal of this, which would be multiplying this side by 5 over negative 3. And the reason I do that is because, first of all, if I multiply negative times a negative, I'm going to get positive. The 5s will cancel and the 3s will cancel, so all you're going to wind up getting here is y. But if I do that here, I have to do it on this side also. So I have to do 5 over negative 3 multiplied through to each of those terms. So on the left side, that's y. But on the right side, what do you get here? This is the part that when you go here to here, you have a negative number times a negative number, which would be positive. Positive what? 5/3 x. And then what happens if you multiply this number times positive 1? You get minus what? 5 over 3? So that, now we have y by itself over there. So what's the slope of this line? Positive 5 over 3, right? So the slope of that line is positive 5 over 3. And the slope of this line is negative 3 over 5. Those are negative reciprocals. And so these two lines are perpendicular. All right, so for this test coming up next week, please make sure you have gotten yourself comfortable solving linear equations for y, where you have fractions and you have to take care of those fractions. Make sure you're comfortable, because that's something that I want to know you can do. All right? Let's look at number 7. This problem is really kind of different than anything we've done up to this point. It says, write the equation for the line that's parallel to that line with the y-intercept of 0, 1. All right. So they give us a line, right? And we're trying to find the slope of a line. What are we trying to find? The equation of a line, right? The equation of a line that's parallel to that line, but has a y-intercept of 0, 1. So I want to show this to you visually again, just so you can understand what we're doing. They give us a line, right? They give us this line. If I asked you to graph that line right now, could you? How? How could you graph that line right there? Where would you start your graph? Okay, so there are two ways to graph lines, right? There's the intercept method, which is the first method we learned, and then we have the slope-intercept method, which is the second one. For this problem right here, this is already y equals mx plus b, isn't it? That's already the form. So we could use the second method for that. We would start where? Where would we start? Go ahead. Please don't talk over one another like that. Raise your hands, please. How would I graph this line? No, it was a good weekend, huh? You had a good weekend?
0 on the x-axis and 4 on the y.
Okay, so start with that number 4, and that's your y-intercept. So you go up on the y-axis 4, and you put a dot here, right? That's 1 point on your line. How do I get a second point? Rise over run. So now we use this part. This slope, that's really -5/1, right? So that means to get to another point, I should go where? From this point, where? Down 5, 1, 2, 3, 4, 5, and then right 1, right there. So I do another point here. Now, that line is given to us, right? Please understand that I'm not showing you what work you need to be doing for this problem. I'm trying to get you to see what we're trying to do, all right? They give us a line. There it is. We are trying to find the equation of a line that's parallel to that line, but has a y-intercept of this. So that means our y-intercept has to be here, right? But it has to have the same slope because, why? Because it's parallel, right? So our line would have to be here and then down 1, 2, 3, 4, 5, and over 1. And then if we draw our line, yeah, those are supposed to be parallel. We're trying to find that blue line, all right? That's what we're trying to find, the equation of it. So the equation of any line can be written this way. We already know this. Where this is the slope, right? Do we know what our slope needs to be? Same as that one because it's parallel. So our line has to have -5x here. And then this number, very important, is the y-intercept, isn't it? And we know the y-intercept of the line we're trying to find. It's what? What's the y-intercept? That's the point, but what's b then? B would be 1. So this would be +1 because that one right there is the b. So that's the equation of our line right there. That's what we want. Understand that? I'm just going to see what the next one is. Let's try it with this one. All right. Same sort of problem. Find the equation of a line. Okay, we are trying to find the equation of a line. We want to know what it is. So our goal is to determine what m is and what b is, right? That's what we have to figure out. Once we have m and b, we have the equation of a line. But what about the line? We have to be perpendicular, right, to that line. We have to be perpendicular to this line and have a y-intercept of 0, -2. So can you tell me anything about this just right now without doing any work? Can you tell me anything? Can you tell me the m or the b right now? Yeah, we're trying to find the equation of this, right? To do that, I need to know m and b. By just reading what's up here, without doing any work, just looking up here, can you tell me what m or b is? B is -2. Okay, right off the bat, we know that. B is -2 because they told us the y-intercept is this, right? So right now, I know that this is going to be -2. The only other thing for me to figure out is what's m. But we're supposed to be perpendicular, right, to that line, which means we need to find the slope of that line and then find its negative reciprocal. And that will be the slope of our line. Well, we have to make sure that this line that they're given to us See, right now the line they gave us is not in slope-intercept form. We have to solve for y. So let's solve for y. So add 10x, gone. We get 2y equals 1 plus 10x. Now what? Divide by 2, right? We'll get y by itself. Divide by 2, divide by 2, divide by 2. We get y equals 1/2 plus 5x's, because 10 divided by 2 is 5. So what is the slope? What is the slope of this line? Be careful. 5, right? It's the number in front of x. So slope of this line is 5, which is same as 5 over 1. So what's the slope of our line going to be? Negative 1 over 5. We're going to take that answer and flip it because we want it to be perpendicular. So this is going to be negative 1/5. Does that all make sense? Does that make sense?
Yeah, it makes sense.
Okay. So y is equal to negative 1/5 x minus 2. There it is. So if I graph this line and I graph this line, they should be parallel, I mean not parallel, they should be perpendicular, right? And this one should have a y-intercept of negative 2 if I graph them. All right, I think that's good. Any additional questions about this? Let's see where we are here with our sheet. So that's it. Now we have the homework. So you should be able to get through all this homework now. You have graphing with the slope-intercept method, and then determining if a slope is positive or negative. So just make sure we're clear on this. We all understand that when it comes to a line, m is the slope, right? If m is positive, you're like this. If m is negative, you're like this. And if m is 0, you are flat line, like this. So this is all they're asking here is determine if it's positive, negative, or 0. So positive, 0, negative. All right, graph these. So this is where you'd be like, okay, start at negative 5 on the y-axis, and then use your rise over run to get to the next point. Same thing there. Lots of graphing here. All right, remember our formula for finding slope, right? y2 minus y1 over x2 minus x1. All of those are examples of that. Find the slope of a line containing these 2 points. So you find the slope here, then find the slope of a line parallel to that, which would be the same slope, right? Find the slope of a line perpendicular, so you do negative reciprocal. All right, I think all of those are just like what we just did right now. Okay, let's move on. Functions and functional notation. So I want to try and make this make sense if I can, because we're going to all of a sudden start talking about these things called functions. So I think it's important for us to kind of have an idea of what a function is before we can start doing this. So have y'all ever seen this before, where you have, like, someone will draw like a bubble and a bubble over here, and then they'll draw an arrow between them, and then they say, like, there's a function that goes from here to here. Have y'all ever seen that before? No? Yes? Yes? Okay. So a function is basically like a machine. It takes in a number and it spits out a number. So it takes in a number, does something to it, and then spits out. But functions are very special in the sense that if you plug in a number, a function cannot spit out 2 numbers. All right? If it does that, it's not a function. So I always like to think of it like a car wash, right? You put a car into a car wash, it comes out like clean car, right? But you can't put a car in and then come out with 2 clean cars. You figure that out and you can make a lot of money, right? So that's what it means. I think it's important because let me write something down here. If I write 2 and I tell you 2 gets sent into the function, it comes out as 4, do you have any idea what that function is doing? It looks like it's multiplying by 2, right? But let me give you a little more information. How about 3 and I tell you it comes out to be 9? Now it looks like maybe it's squaring what's going in, right? Because if you square 2, 2 times 2 is 4, 3 times 3 is 9, right? And then if I plug in 4, if I tell you that that goes over here to 16, I think you'd be pretty convinced, yes, this does look like it's squaring, right? So, can you, if I come over here and I put 25 right here, can you tell me where that came from? Yes? 5, right? But is that the only answer over here? Is that the only thing it would have come from? I mean, I agree 5 squared is 25, but is that the only number over here that would be sent to 25? What about negative 5? What's negative 5 times negative 5? Negative times negative?
Positive.
Positive still, right? So don't both of these get sent here? Yes? So my question to you is that still okay? Is it okay to have 2 different things go to the same answer over here? Yes, it is okay. What you can't have is one number go over here and go to 2 places. If that happened, then it would fail to be a function. Would you like to see something that does that? Just so you have an idea of what I'm talking about? Okay, let me try and show you something that breaks the rule of being a function. So this right here is a function. How about if I drew this picture? And let's say I put in 4 here, and it came out to be 2, but it also came out to be negative 2. That would not be a function, because you have an input 4 that goes to 2 different places. So no function here. So when we're sitting here, we're talking about functions and functional notation. We have to understand that when we write down f of x, that's the way we say that. In words, we say f of x. That's how we would read that. When we say f of x, we are telling the person that's reading this that this expression is very special. That if you plug a number in, it's only going to spit out one number. It's not going to spit out 2. So we are kind of doing that work for whoever's looking at this, saying, hey, look, we promise you that it's going to behave like this and not like this. And that's important later on in math, because functions are a special category of relationships that we have. But I'm getting beyond what you need to know, so just stop right there. So raise your hands. How many of you have seen functional notation before, f of x? Anyone never seen it? Okay, so what does this mean right here? What does that mean? Just in layman's terms, if you're trying to explain that to somebody, if somebody gives you this function, f of x equals 9x minus 5, and they write evaluate f and then negative 3 in there, what are they telling you to do? Replace this x right here with negative 3 is what they're saying. So you're just going to rewrite this. This is going to be 9 times negative 3, that's multiplication, and then minus 5. That's all it means. Replace the x with negative 3. Now, which operation do I do first? Multiplication always comes before subtraction, right? So I would first do 9 times negative 3, which was negative 27, and then minus 5, and that equals negative 32. So for this particular function, if you plug in negative 3, right, it spits out what? Negative 32, right? Takes in negative 3, spits out negative 32. Now, this is saying what happens when you plug in 4. So same thing, we rewrite that. We replace the x with 4, and then we subtract 5. And again, that's multiplication right there, right? So we always do that multiplication first. 9 times 4, 36. Minus 5, 31. This function, when you take 4 in, spits out 31. Now what about number 3? Number 3 is different. Is number 3 asking you to plug 85 into the function? Yeah, it's saying, hey, look, 85 is what comes out. Tell me what went in to give me 85. And even though that looks like it might be difficult, you can really just take this expression, just look at this. This is an equation, isn't it? And don't we know what this is? What is that? What is this right here? That right there, right? Isn't f of x that right there? So can't I just write 9x minus 5 equals and then 85? Did y'all see what I did? I mean, I'm just rewriting this. This is that, and this is that, right? And now we're going to solve this equation for x. Exactly. We're going to try and get x. So like on these two problems up here, they said, plug in a number, tell me what it spits out. We are now saying, hey, it spit out 85. Let's go find the number. The number we plug in is x, so we have to find the x here. So let's solve that. How would you solve this? What would be your first step to solve this linear equation? Add 5. Yeah. Yeah. There you go. That's our answer, right? So add 5 here, we get 9x equals, this is 90, and then divide by 9 on both sides. So x must be 10. So if 10 gets plugged in, we could check it. 10 times 9 is 90. Take away 5, that's going to spit out 85. All right, everything's okay so far? Let's do the next one, part 4. What's f of a? Ooh. So what are we going to do for number 4? What are we supposed to do here? Plug something into the function, right? What are we plugging into the function? A. Well, a isn't a number, right? Okay, who cares? Let's just plug it in. So we're going to take a, we're going to put it right there, right? So this becomes 9 what? A minus 5. And there's nothing you can do to that. You don't know what a is, so you just have to leave it like that. And that's your answer. 9a minus 5. Done. What is f with 2/3 in there? So that means we're going to try and take this and plug it in, right, to the function. So that's going to go in for x. Like that. Yeah, so you have to multiply that. You have to do 9 over 1 times 2 over 3. You know, you could cancel, or you could just multiply 18 over 3. It's going to be 6 when you do this, right? This is 6. So this becomes 6. 6 minus 5, which is 1. Kind of weird, but you plug in 2/3, it spits out 1. Okay, let's look at that last one. What is this last one asking? Is it asking you to plug 0 in? No. It's asking you, what do you plug in to get 0, right? So you have to, again, rewrite this. F of x is 9x minus 5, and then equals 0, right? You want to know when the function is equal to 0. So you solve now for x. Add 5 to both sides, and then divide by 9. So I'll skip the steps, assuming you could get to that. And that's your answer. X is 5/9. So if you plug 5/9 into the function, it spits out 0. All right, so before we do part B, I want us to look at this function we were just working with. Do you all recognize the right side of that as being something we've looked at already? Like, doesn't that look like mx plus b? So if I call this side y, if I just decide to call it y, this would look like a linear equation from the past, wouldn't it? And if we have a linear equation, we can graph it. And this we would start down at -5. That'd be our y-intercept, and we have a slope of 9. So we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1, because that's 9 over 1, and we would draw a line. So can anybody tell me, I'm just curious, from looking at this graph, can you tell me right now what this would be? Just by looking at the graph, what's f of 0? So what happens when I plug in 0? What gets spit out? So x, this is x, right? So x is this way. If x is 0, where's our y? 1, 2, 3, 4, 5. -5, right? How about f of 1? Can you tell me what f of 1 is? So if you go to the 1 on your x-axis, which is here, can you tell me where my point is on the graph? It's this one, right? Okay, what is that one? Remember, we went from here, we went up 9, didn't we? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then over. So what's that distance from here to here? 4, right? This is 4. Do y'all see what I'm saying? So f of 1 would be 4. What I'm getting at is that if you have a good graph, you can answer these same questions we were just answering just by looking at the graph and not looking at the function. But you have to have a good picture. So that's what part B is asking us to do. It's going to give us a graph, and it's going to ask us some questions. I think I can do those just like that. So let's see if we can do this. In the past, students have struggled with this. I'm not quite sure why, but let's try this. F of 3. I need to remember to bring my sticks. I keep forgetting my sticks for this class. I really need them. Because I have the same people answering all the questions, which is fine, but I want everyone involved. I like to hear a variety of voices. I can do it off attendance, but why don't I just go around the room instead? That sounds like more fun to me. All right, that way you know it's coming. So we'll just start over here. So f of 3, any idea?
Maybe 4.
4, so can you kind of explain what you're doing?
So I'm comparing like f of 3 to f of x. So I go on the x-axis, go to 3.
Okay, so this is like your x, so you went to the x-axis and you went to 3. That's 1, 2, 3, and then what?
And then whatever the line is at.
Wherever the line was at. Perfect. Yeah, that's what we're looking at. So you're going out 1, 2, 3. You're saying, hey, where's there a point? The point's here. How high is that point off the ground? 4, right? So the answer here would be 4. All right. That makes sense? Okay, you want to do the next one? What would f of 0 be? So this is our x, right? So go to x is 0, and then try and find where the point is. And how high is it off the ground? Where is x is 0? Right here? Okay, now look up, look down. Where's your graph? Above you or below you? Is it above this point or below the point? The graph of the function. Above? Okay, how high up is it? Right there, right? So how high is that? How high off the ground is that? We just count our units up, right? 1, 2, 3, so we are 4. So it's the same answer. It's weird that it's the same answer, but it's the same answer. Make sense? -10? -6. So you went to -10 on the x-axis, right here. Found the point which was below you. It's down 1, 2, 3, 4, 5. Looks like about right there. Y'all agree that looks like -6? So -6 comes out here. Any questions? What about this one? -3. +1. Let's see, so you went to -3 on the x-axis, 1, 2, 3, and you went, yeah, it looks like +1. Everyone agree? +1? Okay. -4, where are we at? Go ahead, what do you got? -4. So you're going -4 on the x-axis, right? So 1, 2, 3, 4, and then where's your graph? It's right there, isn't it? Like you're on it, aren't you? So I'm going to draw a dot. How high up off the ground is that dot? It's not, right? So we just say 0. Everyone clear? Okay, there's more? Oh yeah, number 12. So Robert, you want 12? 12 is a little different. So it's saying, for what value of x, of x, is the function equal to 3? So what are you thinking there, Robert? Does everyone see the difference between 12 and the others? Any ideas? 0? No, what do y'all think? -1. So Robert, when it says where's the function 3, it's actually saying where's the height 3? Like when are you 3 units off the ground on this function? Instead of going to 3 and then finding your point, you're saying when are you actually 3 units off the ground? And I think, let's see, this is 1, this is 2, this is 3. I think that only happens there, right? Doesn't it look like we're about 3 units off the ground there? And what is the x that would send us to that point? So we have to come back down and find our x value right there, and that looks like it's -1. Do y'all see a difference between that? It's backwards now. What?
I thought I messed myself for x because I was trying to graph.
Oh yeah, okay, so normally in the previous problem we solved for x, didn't we? But they gave us the function, didn't they? They gave us 9x minus 5. See here, they don't give us a function, they just give us a picture. So all of our information is coming directly from the picture. We have no function given to us other than that, okay? So we don't have any choice but to just look at the graph and come. All right, let me ask you another one. I think that, oh no, there's more. Good, there's more. But it's gonna be hard to get the graph on here. Let me go a little smaller. Bless you. What's up? Sir, you ready? You got number 13. So for what value of x is the function 1? -3? What do y'all think? Yes or no? Okay, let's see. So you're looking at where the function is 1 unit high. Here's 1 unit up. You went over here, you said there, and then you came back down to the x-axis, and it looks like -3. I agree. X is -3. All right, you ready, sir? All right, you got 14. So where's the function 0? Pardon?
In the middle.
Okay, so what is the x? What is the x that gives you 0? -4, right? -4. Everyone see that? So this one is a little weird because you have to go, where's your height 0, which is the one you did, but we're going the other way around, right? So where's the height 0 at an x value of -4? Do y'all like those or not? I mean, usually when students understand this, like they want me to put this on the test because it's like, I can do this all day long, right? So are y'all okay with those? Yeah. Okay. We'll just have one problem on the test. This will be it, right? No. All right. Okay, I think that's good. 10:30.